Before start this video, please subscribe my channel and click on bell icon. Thanks.
Cas A represents our best opportunity to look at the debris field of an exploded star and run a kind of stellar autopsy to understand what type of star was there beforehand and how that star exploded, said Danny Milisavljevic of Purdue University in West Lafayette, Indiana, principal investigator. Compared to previous infrared images, we see incredible detail that we haven't been able to access before, added Temim of Princeton University in Princeton, New Jersey, a co-investigator on the program. Cassiopeia A is a prototypical supernova remnant that has been widely studied by a number of ground-based and space-based observatories, including NASA's Chandra X-ray Observatory. The multi-wavelength observations can be combined to provide scientists with a more comprehensive understanding of the remnant. Dissecting the image, the striking colors of the new Cas A image, in which infrared light is translated into visible light wavelengths, hold a wealth of scientific information the team is just beginning to tease out. On the bubble's exterior, particularly at the top and left, lie curtains of material appearing orange and red due to emission from warm dust. This marks where ejected material from the exploded star is ramming into surrounding circumstellar gas and dust. Interior to this outer shell lie mottled filaments of bright pink studded with clumps and knots. This represents material from the star itself, which is shining due to a mix of various heavy elements, such as oxygen, argon, and neon, as well as dust emission. We're still trying to disentangle all these sources of emission, said Ilse de Luz of Ghent University in Belgium, another co-investigator on the program. The stellar material can also be seen as fainter wisps near the cavity's interior. Perhaps most prominently, a loop represented in green extends across the right side of the central cavity. We've nicknamed it the Green Monster in honor of Fenway Park in Boston. If you look closely, you'll notice that it's pockmarked with what look like mini bubbles, said Milisavljevic. The shape and complexity are unexpected and challenging to understand. Origins of cosmic dust, and us among the science questions that Cas A may help answer is, where does cosmic dust come from? Observations have found that even very young galaxies in the early universe are suffused with massive quantities of dust. It's difficult to explain the origins of this dust without invoking supernovae, which spew large quantities of heavy elements, the building blocks of dust, across space. However, existing observations of supernovae have been unable to conclusively explain the amount of dust we see in those early galaxies. By studying Cas A with Webb, astronomers hope to gain a better understanding of its dust content, which can help inform our understanding of where the building blocks of planets and ourselves are created. In Cas A, we can spatially resolve regions that have different gas compositions and look at what types of dust were formed in those regions, explained Temim. Supernovae like the one that formed Cas A are crucial for life as we know it. They spread elements like the calcium we find in our bones and the iron in our blood across interstellar space, seeding new generations of stars and planets. By understanding the process of exploding stars, we're reading our own origin story, said Milisavljevic. I'm going to spend the rest of my career trying to understand what's in this data set. The Cas A remnant spans about 10 light-years and is located 11,000 light-years away in the constellation Cassiopeia. Thanks for watching. Please subscribe my channel for more videos.